Class, what's up, and welcome to Chapter 8. We're getting into right triangles, alright? So Chapter 8's everything's going to have to do with right triangles. It's going to involve some Pythagorean Theorem, as you can see here. And then we're going to we're going to introduce you to right triangle trigonometry, Alright, so before we get to the crazy trig stuff, let's work on something that hopefully some of you guys already have some understanding of, which is the Pythagorean Theorem. Okay? The theorem states that in a right triangle, the sum of the squares, I goof that up every time. The sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse, alright? So, very important for us to always understand and label that I know across from the right angle is always the hypotenuse, which means my other two sides are legs, which means then that I know what I need to add together, what I need to first square and add together, I know it says that I need to find the sum of the squares of the lengths of the legs, okay? So I need to square a squared, I need to square b squared, and it tells me to find the sum, so plus. Now, it doesn't necessarily matter which side c squared goes on. I tend to put it in the front now. C squared is equal to a squared plus b squared. This comes later on, okay? The reason that I put c squared out in front is for a reason that we'll see in a little bit. If you memorized it as a squared plus b squared equals c squared, by all means, do not freak out. You don't have to switch if you don't want to. I just think it might be beneficial a little bit later on, and we'll get into that. All right? Now, a Pythagorean triple is a very specific situation in which a set of three non-zero whole numbers, a, b, and c, such that c squared equals a squared plus b squared, is called a Pythagorean triple. Alright? Basically, this is just saying that the three values a, b, and c are all really nice numbers. Okay? They're all integers. So, some examples is 3, 4, 5. Like if I drew that picture, 3, 4, 5, well, what would I have to do? I'd have to do 3 squared plus 4 squared is equal to 5 squared, or 9 plus 16 equals 25, or 25 equals 25. Okay, so the fact that these three sides are all integer values makes it a triple. So 3, 4, 5 is one. Let's see what others. 5, 12, 13, 7, 24, 25. And then the last one I remember, 8, 15, 17. These are the four that I always keep in the back of my mind. There are infinitely many more, but I don't memorize too much after that. I think there's also 9, 40, and 41, whatever, but okay. So you know that if you see a situation like this, where you have a hypotenuse of 5, a leg of 3, well, you automatically know that that last leg has to be 4. Be very careful, though. I knew it was a right triangle. If this hadn't been a right triangle, then everything's out the window. Okay? Okay. Now, as we move on, the converse of the Pythagorean theorem is basically the exact opposite. I guess that's not the right way of putting it. If you remember, every time we talk about converse, it's like if A, then B. Well, now we're saying if B, then A. Hopefully we remember that. Okay, so if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. Sorry, I got a little confused when I was reading that the first time. We can't call them legs, right? Because they're only legs once you have a right triangle. And if we're trying to prove that something's a right triangle, then we don't know if it's a right triangle or not, okay? So basically, we need to say if the sum of the squares of the lengths of two sides, and these will be the shortest sides, is equal to the square of the length of the third side, and of course that third side is going to have to be the longest side, then the triangle is a right triangle. So we look at this picture, we have A and B and C, and then it's telling us that A squared, or a leg squared, side squared, plus this other side being squared is equal to the third side being squared. So we can say triangle ABC is a right triangle. We also can say that angle C is a right angle. Okay, put that one in parentheses because that's just kind of an extra. Alright, last little bit here. This is why I start to put C squared out in front. Alright, so when we look at this, in triangle ABC, C is the length of the longest side. Alright, the longest side. C always has to be the longest side. And then we know that, well, actually, let's go over the one that we already know. I'm going to put it right here in the middle. If C squared is equal to A squared plus B squared, then triangle ABC is a right triangle. Let that sink in. We've already talked about this. If C squared is equal to A squared plus B squared, then triangle ABC is a right triangle. We did that up above. Now we're saying that we have ways to tell if a triangle is an acute triangle or an obtuse triangle by using inequalities. Alright? So if C squared, or the longest side being squared, is greater than the sum of the squares of the other two sides, well then we're going to call that an obtuse triangle. And then if C squared is less than, well then we have an acute. Alright? So again, I put C squared out in front because now I see my greater than sign and I just think obtuse because it's bigger, and obtuse is bigger than 90. I see less than or less than for acute. If you flip it, it works the same way. You just have to remember that all of your inequality symbols will be switched. Okay? Okay. So now that we've gotten that out of the way, we want to do some work with the Pythagorean Theorem, and even before that we have to kind of teach you a little bit about your calculator, because the calculators can be your best friend. So if I look at something like the square root of 200, right, if that's a side length and I need to simplify it, well, the old-fashioned way would be to take this 200 and just continuously break it down, right? 200 goes to 2 and 100, and 100 goes to 2 and 50, and 50 goes to 2 and 25. And then I'd probably stop there because I know 25 is 5 and 5. Okay? And what we say is that anything that has a pair comes out from underneath the radical bar, and anything that does not have a pair has to stay underneath. So again, because I have these 2's, I know I have a 2 outside of the radical bar, and because I have a pair of 5's, I have a 5 outside of the radical bar, and then I have this lonely 2, so that has to stay underneath the radical bar. And when I clean this up, 2 times 5 is 10, and then 10 times radical 2 is just 10 radical 2. Now, if you want to do these by hand, or your calculator doesn't do what I'm about to show you, then this is good. You should probably rewatch. But I'm here to tell you that if you have one of these nice yellow calculators and you punch in the square root, let me do that again, the square root of 200, it gets you your answer in simplest radical form. Okay? So again, just for those people that don't have this calculator, I'm going to do this 180 over here. And I'm going to break it down. So 2 and 90, 2 and 45, 3 and 15, 3 and 5, and that's as broken down as it can go. So what do I have? I have a pair of 2s and a pair of 3s, and then a 5 underneath. So I'd have 2 times 3 times radical 5, or 6 radical 5. When you go to the calculator, square root 180 is 6 root 5. Okay? So if you have a yellow calculator, then a lot of this work is going to be done for you, which is awesome. Okay? Okay. As we move down to the bottom and we start applying the Pythagorean Theorem, my first suggestion is always, especially if you already have a right triangle, please label A, B, and C. Now, A and B don't necessarily matter because they're both legs, but C is super important. You know that if you have a right triangle, the C value must be across from the right angle. And then again, A, B doesn't necessarily matter. But now, what do? Well, we apply the Pythagorean Theorem. We say 6 squared plus 8 squared equals, let me put it over here, C squared. Oh, and I should have replaced, I knew that this is going to be x squared. Sorry, guys. Alright, so x squared, because x is my C value, or C side, x squared is equal to 36 plus 64. X squared equals 100. And then we have to square root both sides, so x is equal to 10. Alright, so x equals 10. And then I look, how do I tell if it's a triple or not? Well, I just have to have 3 nice non-zero whole numbers. 6, 8, 10. Oh yeah, for sure. Because 3 non-zero whole numbers. Alright, easy enough. When I move on to the next one, again, I label. I see that across from my right angle, must be my C value, and then it doesn't necessarily matter where you put A and B. But now I know, again, C squared, or 13 squared, must equal A squared. That whole thing squared, plus B squared, or X squared. Okay, now this is where calculator can come in handy. 13 squared, what do we got there? Oh, 169. 169. What happens when I have the square root of a number, and then I square it? It just becomes that number. Alright, so 169 minus 37 is 132. And then, of course, I need to square root both sides. So x equals square root of 132 is 2 root 33. 2 root 33. So I rewrite it as my final answer. And then hopefully, guys, this should make sense. This is definitely a no. Why? Because the square root of 37, or 2 square root 33, if I change this to decimal form, and I can do that by hitting these double arrows down here, that's a decimal, right? That's not a whole number. Okay? So really, it's because not 3 non-zero whole numbers. Okay? Okay. So, we will skip number 6 for now. Maybe you guys can try that one on your own. And we will do something a little tricky. Alright? When we ask you to find this x value here, it can definitely get a little confusing. So, let's take a look now. Alright, same thing. I have a right triangle, so I know that across from the right triangle needs to be C, and then my legs can be A and B. So I know c squared has to equal a squared plus b squared. So I start to write it. And actually, just to kind of help us out, c squared is equal to a squared plus b squared. All right. Now, when I plug in everything, I get that this left side, will be x squared, right? That's my c side. Now my a, I chose a to be 5, so I have 5 squared. And then here's a tricky part. I have x minus 1, this whole side, being squared. Alright, now the first couple parts are not too bad. This stays, this becomes 25. You guys need to remember back from Algebra 1, when I square x minus 1 squared, you do not just square x and you do not just square 1. That is unacceptable to me, okay? We need to remember that when you have a quantity being squared, you actually have 2 of the entire quantity being multiplied by each other. And so, yes, you are going to have to distribute. All right, double distribute, FOIL, whatever you want to call it. But yeah, we need to figure out what this is equal to. Okay, so I keep going. X squared is equal to 25. Well, when I start to distribute, I get an x squared. I get a negative x. I get another negative x. And then I get a positive 1 plus 1. Great. Let's start to clean this up. X squared is equal to 25 plus x squared minus 2x plus 1. Oh, this is not bad at all. X squared equals x squared minus 2x plus 26. I guess I could have combined that on the last line, excuse me. Alright guys, here we go. You need to understand, when we start to solve this, we need to get x's on one side, constants on the other. Well, when I move this negative x, or when I move this x squared over, what happens? They cancel. Alright, that's great. I now have 0 is equal to negative 2x plus 26. Don't freak out. I know we don't like zeros on a side, but we know what we can do. We still need to move these x's over. So I'm going to add my 2x and add my 2x. And now I know that 2x is equal to 26, or x equals 13. Alright? So now I know that x is equal to 13. I have to make sure, because it's still asking whether or not this is a triple or not, that I plug it in. Alright, well I knew this side was 5, so that's good. I knew this side was 13, that's good. Well, x minus 1, 13 minus 1, that's a 12. Holy cow, 5, 12, 13. Wasn't that on our other sheet? It absolutely was. Okay, this is one of our triples. So we would know that, yes, this is a triple. Okay. If you had trouble conceptually with that one, I think what I'm going to do is I'm going to save 8 to do in class with you guys. Alright? So we are going to skip number 8 for right now, and we're going to move on to our very last page of notes, because this video is already pretty long. Okay. So last thing from the notes that we've talked about so far is classifying as acute, obtuse, or right. And if you remember, if I use, and this is kind of what I try to do to show some work, I put my c squared, and then I put a box, and I put a squared plus b squared. Because I know that to fill in this box, it depends. If it's acute, c squared is going to be less than. If it's obtuse, c squared is going to be greater than. Or if it's right, it's going to be exactly equal to. Alright, so that's kind of the work that I show. Let's take a look. Alright. Please remember, it has to go in order. You have to order things. So for this, I know that 10 is going to be my longest side, so this is going to have to be C, B, A. So let's take a look at what goes on. When I do c squared, a squared plus b squared, plug everything in, so I get 10 squared, I don't know. Oh, what am I doing? Sorry guys, let me rewrite this. Okay, 10 squared, and then my a squared is going to be 4 squared plus 8 squared. Okay, that's better. Sorry about that. Guys, use your calculator. Don't leave room for error. If you're not great with your squares, please just use your calculator. I know that this side is 100. I know that 4 squared is 16, and I know 8 squared is 64. So when I add these together, I get 100 box 80, and I know that 100 is greater than 80, which means because c squared, or the third side, the square of the third side is greater than the sum of the squares of the lower two sides, or smaller two sides, I know that this is going to be obtuse. Alright? Now we need to be careful. Both 10 and 11 have square roots in them. And so, well, I don't know. I mean, 11, 16, 5 root 7, this looks like it might be the smallest side, but do we know for sure? We do not. So this is where you need to use that trick that I showed you earlier. You have 5 root 7. Good. And then if you hit the double arrows right here, it goes to decimal. So now we know that this is about 13.2. Now we don't use that, but we need to have it so we know what's A and B and C. Because now I can order. I know 11 is my smallest, 13.2 is my middle, and 16 will be C. So now when I do c squared, a squared plus b squared, I know I'm going to do 16 squared, and then 11 squared, and then I'm going to do 5 root 7 squared. Again, please do not use the rounded value here. That'll mess everything up, and you won't get a nice number. Okay? Cool. Well, let's go to work here. 16 squared, we have 256, and we have 121, and then 5 square root 7 squared is 175. Okay, so 175 plus 121 is 296. So we have 256, 296, and then of course we know that this is going to be a less than symbol, which means then the triangle that would be formed here is acute. Alright, so this is a good example of one where you don't necessarily need to see a triangle, you just need to know the order of the sides. Alright, I think I'm going to call it there for today's video, and we'll do a few more of these example problems in class to help warm up before your practice. Alright, so again, if anything's not making sense, feel free to re-watch something, email me, ask questions tomorrow when I see you. Alright, have a good one. Peace.